All right, taking a look at example 3. A ladder, which is 4 meters long, rests against a vertical wall. If the bottom of the ladder slides away from the wall at a speed of 30 centimeters per second, how quickly is the top of the ladder sliding down the wall when the bottom of the ladder is 2 meters from the wall? So once again, we're going to draw a sketch of what this looks like. So I have a vertical wall. I have a ladder that's leaning up against the wall. And I have the space in between the base of the wall and the bottom of the ladder. Now I know that it is sliding away from the wall, so that value is changing. And I know that the ladder, as that happens, is going to slide down the wall. So that value is changing. So my x is increasing, but my y is decreasing. I also need to make sure that I check the units here, and we should notice right away that this is in meters and this is in centimeters per second, which means that I'm going to change my meters to centimeters. So I'm going to say that this 4 meters is equal to 400 centimeters. I'm going to define my variables, and I'm going to let x equal the distance from the bottom of the ladder to the base of the wall, and I'm going to let y represent the distance from the top of the ladder to the base of the wall. And as per usual, t is going to represent our time. And in this case, it's time in seconds. Now, what do I know? I know, given my problem, that dx over dt, how far it's sliding away from the wall, is 30 centimeters per second. I know I'm trying to find dy over dt, and I know that this is when x is at 2 meters, which we're going to change to 200 centimeters, because once again, we got to make sure that we do appropriate units. It's still a right angle triangle, so I'm just going to use Pythagorean theorem. And I'm going to state that x squared plus y squared is equal to 400 squared. Well, when I differentiate this, what happens? I have 2x and dx over dt plus 2y dy over dt, and 400 squared is just going to give me a constant, so that is going to be 0 when I differentiate it. But what do I see here? I see that I have x, I have dx over dt, I need dy over dt, but I'm missing y. Well, I have enough information to solve y from this Pythag. So I'm going to do that right now. I'm going to say that if 200 squared plus y squared is equal to 400 squared, then that means that y squared is going to equal 200 squared 400 squared minus 200 squared, not the other way around. Or y is going to equal the square root of 400 squared minus 200 squared, which is going to give me the square root of 120,000, which I can reduce to 200 root 3. So I do have enough information to solve that other piece of missing information. Then I can sub it in, and I can say that 2 times 200 times 30 plus 2 times 200 root 3 times dy over dt is going to equal 0. Well, that's going to give me 12,000 plus 400 root 3 times dy over dt is equal to 0, or 400 root 3 dy over dt is going to equal negative 12,000, which means that dy over dt is going to equal negative 12,000 over 400 root 3. And I can divide the top and the bottom by 400 and get negative 30 over root 3. I'm going to rationalize that to get negative 30 root 3 over 3. And I'm going to divide out the 10 to get negative 10 root 3 centimeters per second. I did get a negative answer, so it seems to make sense given the problem. And I'm going to say, therefore, the ladder is sliding down the wall at a rate of 10 root 3 centimeters per second when the bottom of the ladder is 2 meters from the wall.